Hello, everyone. Again, it's a good day to learn. And let's take a look at the issues surrounding the classless or the classful IP addressing and see what can CIDR do to solve those problems. The IP addresses that are assigned throughout the entire world is controlled by an agency called Internet Assigned Numbers Authority. So they are responsible for assigning a portion of that IP address on a per region basis. Like, for example, the American Registry of Internet Numbers is responsible for assigning a piece of that IP addresses to the American continent. Similarly, we have the APNIC for the Asia Pacific and other agencies. But again, when a certain portion of an IP address is assigned to you, you will be able to determine easily the location of that person connecting to the internet. So that's why when you have a service, let's say Netflix, and that is not allowed to be viewed in your country, simply using or checking the IP address will determine in what country you belong to. Similarly, those IP addresses are further subdivided into secondary markets. Like in our case in the Philippines, if you have PLDT, Globe, and other telco players, the PLDT is assigned also a bulk chunk of IP address that they could give to their customers. In that way, you could actually determine if you are a subscriber of PLDT, Globe, or other telcos. Let's take a look again at the classful IP addressing with classes A, B, and C. Note that the network address is prefixed with 0, 10, and 110 for each of those classes. So in effect, in class A, if you prefix it with a 0, the numbers, the range of numbers that can be used for the network is effectively reduced from 1 to 126 for class A, 128 to 191 for class B, and 192 to 223 for class C. The problem with the classful IP addressing is the class sizes. Either it becomes too small to be useful, or it's way too big for a certain number of computers. Let's say, again, my example, if you have 300 computers, the closest that you can have for that is either 254 class C or the 65,000 class B. The 254 is too small for the 300. Therefore, we will have to move on to the next class, which is 65,000. But again, that's way too big for that particular requirement of just 300 computers. So that's where the problem is for a classful IP addressing. The limitations of that scheme or mechanism of assigning IP addresses is that we have a lot of wastes. We have a lot of unused IP addresses. Again, in this example, if you have only 2,000 computers, we will have to move on to class B. And this pie chart will show you that we have wasted about 63,534 IP addresses as opposed to only using 2,000 IP addresses. Okay, so that particular issue has been emphasized many, many times, and that's what we are going to resolve in the CIDR addressing. Here we go. So classless interdomain routing, we pronounce as CIDR, or simply put CIDR. The idea here is to get rid of the IP addresses. And then we would like to arbitrarily split between the network and the host so that we could at least a little bit give a more precise number of IP addresses for a certain group of computers. And similarly, the IP address notation will be changed from a combination of IP address and a net mask into this kind of notation with a prefix at the end. Again, remember that an IP address is a 32-bit IP address in a binary notation. So now, the objective of this CIDR is to be able to move this slider here so that we could get a certain portion of the host, or we could reduce or increase the portion of the host so that we could get a closer value as required in the number of computers that we need to have IP address assigned to, right? So this is the decimal notation again, 10.217.123.7, and it is comprised of 4 octets. Those 32-bit IP values will be divided again similarly to network ID, and on the other side is your host ID. This is the binary notation for that one. So it's important that you know how to read, write, and compute using binary numbers. Okay, let's have a short review on binary. Here we have 8 bits. Every position of that bit has a corresponding decimal equivalent. So the first bit is 1, the second bit is 2, 4, 8, 16, 32, 64, and 128. So mathematically, actually, 1 here is 2 raised to 0, which is 1. This is 2 raised to 1, which is 2. 2 raised to 2, which is 2 times 2 is 4. And 2 raised to 3, which is 2 times 2 times 2 is 8, and so on and forth. So if you look at it, it's just simply multiplying. 1 times 2 is 2, times 2 is 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048. So get used to that kind of multiplying, because those are the numbers that are always present in our IP address notation, right? Let's have another example here. So we have 101, 00, 000 as the first example. So you just have to get the equivalent decimal value as shown in the image above. So 128 plus 32, and that gives you 160. In the second example, you have 111, 11, and 3 zeros. So you simply add the equivalent decimal for all those 1, which is 128, 64, 32, 16, and 8, and the rest are 0, and that will give you 240. Here's a table that will explain further the relationship between binary numbers and the net mask. The net mask is the subnet mask or the network address, as we have discussed. No? So don't be confused by that. Subnet mask, net mask, network address, they are all the same. Since in the diagram, the network address is always on this side and the host address is on the other side. Okay? If the first bit is 1, your value is 128. If 2 bits will be 1 for your network mask, you have 192, 224, 240, until you reach 255. When all the bits of that 8-bit octet is 1, you have 255. So in short, in a network address, net mask or subnet mask, it will always end with either 128, 192, 224, and any of these numbers. No more, no less. You don't have a net mask that ends with 194 or 1 or 0 or more than 2 or anything in between this, right? So get used to this one. Try to memorize, familiarize with those numbers so that when your subnet mask ends outside these values, something is wrong with your computation. Now, moving from classful to CIDR notation, before we have to write the IP address in a pair of the IP address plus the subnet mask. So in the table, A class A will always have a 255.0.0.0 as a subnet mask, and the CIDR notation will be, we will have to have a suffix of /8 because there are 24 bits in it remaining for the host and 8 bits allocated for your network, right? So, in example, so 192.168.10.10 subnet mask 255.255.0. When you write that into a CIDR notation, it becomes /24. So where this 24 came from? The 24 is representing the number of IP addresses that were allocated for the network. So that is 255, which is 8. Again, 255, another 8, and 255 is another 8, that's 24. Okay? So the second example, 10.5.8.7, the network mask or subnet mask is 255, so that's /8 only. Right? Next. The problem here is design a network with 300 host computers using the private IP 192.168.x.x. So let's say, for example, the given is 192.168.10.10. So we know for a fact that the subnet mask of this is 255.255.255.0 because 192 is a class C. Okay. So all in all, it has 254 bits. Look at this. If we convert this into an IP address, you will get this notation. So the 255.255.255, the orange is the 0 here. This is /24. That is the binary representation of the one above. So no question about that. We have discussed that many, many times. Now, we take note that given this combination of numbers, we will only be given an IP of 254. That is not enough because we wanted 300. So what if we are going to adjust a little bit, no? So increase the size of the host, get one from the network like this, and make this as part of the host. So your host now becomes 8 plus 1 bit is 9 bits all in all. So therefore, if you have 9 bits, that will be 2 raised to 9 minus 2 is 512 minus 2, which is equals to 510. Just enough for the 300 host computers that we need. So in that example, if it becomes /23, the IP address notation will now be 192.168.10.10/23. Not much have changed except for the subnet mask. If you take a look at the subnet mask, because we remove a 1 bit here, the 254 became the 255 there became 254 already. So minus 1. Right? Moving on with this example, we have to get the network address followed by the broadcast address and then the usable IP address. So we have already determined that the subnet mask is /23. That is enough to give us 500 hosts. So as usual, to get the network address is you have to copy all the bits above the subnet mask with 1 and then make all the hosts 0. So you copy all the bits that are over the 1. So that's it. And then we make all the remaining bits we make all the remaining bits 0. So that's why it became like this. So 192.168.10.0. And then, if you are going to convert that into a broadcast address, you will simply convert the remaining bits to 1. So instead of 0 this time, we will make them 1. And that's where you get the broadcast address, 192.168.1 or 11.255. And then to get the usable IP addresses, anything in between, the network address and the broadcast address will be your usable IP addresses. So it starts with 10.1 and ends with 254. So all in all, you will be having 510 hosts for these usable IP addresses. That's from 1 up to .11 to 254. That will be 510 usable hosts for that notation. Okay? Few more example. So, what is the network address of the IP 202.192.15.1/25? So, /25 is a class C plus 1, right? So, this time, we have increased the number of networks to this portion. So, the address, when converted to binary, you get this. Okay. The same process is we get the network address is to simply make all the bits 0, like this one. So when we translate that, you have all the bits 0. Remember, we only have 7, no, not 8, 7 bits remaining. So we make that a 0, and then the result will give you 202.192.15.0. And then if we convert this 7 remaining bits into 1, it will give us the broadcast address, which is 202.192.15.127. Okay? And then the IP range is we take the first IP after the network and ends to the IP address just before the broadcast address, which is 1 up to 126. I'm sorry, this should be 126. It should be 202.192.15.1 up to 15.126. Right? Okay, that's it for classless interdomain routing, and see you again in the next videos.